Hi. Today in class we worked on the area model of multiplication with mixed numbers, as well as turning mixed numbers into improper fractions, which I call the checkmark method, to check our work. So they have to do two methods when they are doing the area model, just the area model and the checkmark method. Their homework looks like this. It is from their books at school. It is lesson 7.7. We're going to walk through number 1 real quick just so that they can get a handle on how to do number 2. We did a problem like number 1 and 2 in class today, but I want to go ahead and walk through number 1 as well. It says, let each square represent 1/4 unit by 1/4 unit. So, real quick, I'm going to draw a grid on my whiteboard. And it's not going to be perfect, but you're going to pretend that these are perfect little squares, even though they're not. Alright, so, see, not that, the bottom is definitely horrible. So, we have a 2 1/4 by 1 1/2. Alright, so this is not the area model. This is just using a grid to try and figure this out as like a real life situation, like having to tile a floor or figuring out, the area of the floor, then these are little tiles. Some pertinent information they gave was 1/4 by 1/4. That is the length and width. See, 1/4 by 1/4. So each little square, because it's a square since it's 1/4 by 1/4, length times width is area. Area equals length times width. So what is 1/4 times 1/4? That's right, it's 1/16. So that is 1/16 units squared, and in this, it says units. That's why I said units squared, and I can't fit the word units squared in there. But that would be the area of just one of those squares. The length, though, of this side is 1/4, and the width is 1/4. So if I'm measuring things to draw out, I have to remember that that's just 1/4 long. Because 2 1/4, I asked the kids today, how many fourths would be in 2 1/4? And there would be 9/4. That's what creates 2 1/4. How did I get that? Well, 4/4 plus 4/4 is 8/4. That would represent 2. Plus 1/4 is your 9/4, or check mark it. Multiply, 2 times 4 is 8, plus 1 is 9. So turn it into an improper fraction. That means that I have to draw 9/4 down. Because, again, we're pretending these are perfect squares, which they are not. And we got to go 9 of them down. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, they're not perfect. You can tell it's way smaller than it should be. And then across is supposed to be 1 1/2. So how many fourths are in 1 1/2? 4/4 would be in 1. 2/4 would be in a half. So 4 plus 2 is 6/4. So I need to go 6/4 across. 1, 2, 3, 4, 5, 6. And again, not good because of how long they are and short. So where did I get that from? 9/4 again would be in, that's how many fourths are in 2 1/4. So then each one of these lengths, remember, is a fourth. So a fourth plus a fourth plus a fourth, 9 times. That is what's representing 2 1/4. So that's the length right there, 2 1/4. And over here we went 6/4, which is 1 2/4, or also known as 1 1/2. And then see, I can't find the area of this figure because we don't find the area of open figure. We find the area of rectangles and squares. So I need to close my figure by just going across and going down equal amounts to close it off and make a rectangle. And of course, again, because my thing is messed up, number 1 is actually should be longer than it is wide, because if I had perfect squares, 9 squares is more than 6 squares across. But again, since I don't have a nice drawing there, so then, how many squares are in this area, in this diagram? So we got 1, 2, 3, 4, 5, 6. Sorry about that. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, that's an array. It's a 6 by 9 array. That means there's 54 squares in that diagram. So again, if they were perfect squares, there would be 54 squares there. So that's information that is good to know. There's 54 squares because you guys already told me the area of one little square was 1/16 units squared, or square units. So if I have 54 of these and they're each worth 1/16, then aren't I just doing 1/16 times 54? Because we don't want to add 1/16 54 times, do we? Right? I don't think you do. I know I don't. So 54 times 1/16 would be a total of 54/16, right? Units squared, because remember 1/16 was units squared. They're probably not going to ever let you keep it as 54/16, right? So how many times does 16 go into 54? That would be 3 times, which is 48. And 54 minus 48. Right? So that would be 6/16. And at this time, people might be saying, well, that's not the same answer that's written on this paper. Well, that's because, see, we're supposed to be in 16ths since every square is worth 1/16, and they just chose to reduce 6/16. If you divide 6/16 by 2 halves, then you get 3 3/8. I'm perfectly fine with 3 6/16. However, as you get older, they are going to make you what you call simplify. So that is why you see the 3 3/8 units squared. So that's why, see, these two are equivalent to each other. Divide by 2 halves, 6 divided by 2 is 3, 16 divided by 2 is 8. So that is where that information is coming from. So the kids are supposed to do number 2. In the number 2, it says, let each square represent 1/3 unit by 1/3 unit. So that is our key information. That is telling us how long and how wide everything is. So again, you've got a perfect grid, which I don't have. So again, you're going to have to pretend that mine is perfect. Okay, so here's your grid. And I am supposed to be representing 1 2/3 by 2 1/3. By also means to multiply, right? And so the information they gave me, which was lovely, length and width equals 1/3. We did a problem just like this in class as far as we had a 1/3 by 1/3, which means the area is 1/3 times 1/3, which means the area of each little square is 1/9 units squared. And again, it's because they said the word units and not giving me meters or miles or whatever. And that's a horrible sloppy units squared. But 1/9 units squared. And they want me to draw 1 2/3. So how many thirds are in 1 2/3? Well, 3/3 are in 1, plus 2/3 would be 5/3. Or if you check mark it, 1 times 3. 3 plus 2 is 5. So again, 5/3. So I need to draw 5 down. So I'll switch sides here. So 5 down, 1, 2, 3, 4, 5. Because that's 5/3 or 1 2/3, right? Now, I'm supposed to go 2 1/3 across. So, 2 1/3, how many thirds are in 2 1/3? Well, 2 times 3 is 6, plus 1 is 7. 7 thirds are in 2 1/3, because 3 thirds plus 3 thirds, which is 6 thirds, that's 2, plus 1/3, 7 thirds. So I gotta go 7 across. 1, 2, 3, 4, 5, 6, 7. That represents 2 1/3 units. And again, I can't take the area of that. It's open figure, so we need to go ahead and make our rectangle. And again, I know it's a rectangle because those units aren't the same. If they were the exact same, then it would be a square. So now I need to find the area of this diagram. So again, how many squares there are. So that number of squares times 1/9. Why? Because the area of each square is 1/9. But I don't think you want to sit here and go 1/9 plus 1/9 plus 1/9 plus 1, blah, blah, blah. You want to figure out how many squares are in your diagram that you drew, and you want to multiply that by 1/9. And then you probably have to turn that into a mixed number because you're going to get an improper fraction. And don't forget units squared because area squarea. Okay, then they worked on something called the area model, and they took notes. They were supposed to take notes. and because in middle school you're going to take notes, they're not going to make videos for you necessarily. So we're going to do number 4 together. They have to do 3 and 5 doing what I'm doing, but I'm going to do it with number 4. So what they're doing is doing the area model first. So the area model is separating into expanded notation the parts of the problem. It's partial products. So number 4 says 2 2/3 times 1 and 1/3. So I need to do this in expanded notation, which would just be 2 plus 2/3. So I'm just separating the whole number from the fraction. So 2 plus 2/3. Okay? That's a horrible rectangle. I know it should be going there. Better. Now 1 plus 1/3. So again, separating the whole number from the fraction. So I'm just adding that plus in between because it's 1 plus 1/3, which is a total on this side of 1 and 1/3. I cut it where I make my plus signs to make 4 different areas. So I'm going to find the area of this one, which is 2 by 1. How do I know that? Here's my 2 across. The 1 is first. So if I wanted to get rid of that plus sign, I can see that the 1 is this height. If you want to move it down, that's fine. I don't care. So 2 times 1 is 2. 2/3 times 1 is 2/3. 1/3 times 2/3 goes here, so that would be 2/9. And 2 times 1/3, that's like 1/3 plus 1/3. Repeated addition, right? 2 sets of 1/3. 2/3 would be that. And look, I've got a common denominator. I've got thirds and ninths. I can't do that. So I need to go ahead and convert these to ninths before I move on. I have to add them all together. So I might as well get equivalent fractions now. So 2/3 as far as ninths, that would be times 3. So I need to do this times 3. Because it's times 3/3, not times 3. So it's 6/9. Well, this was the same thing, so good. That works out well for me. That's also 6/9 then. Now I can add them all together. 2 plus 6/9 plus 6/9 plus 2/9. Now there's no other whole number to join this 2. That's a 2. It doesn't look too good. Better? So I know that 2 is still there by itself. There were no other whole numbers here. But I've got 6 plus 6, which is 12, plus 2, which is 14. And I'm sorry, you guys can't leave it that way, 2 and 14/9, because 14/9 is not compatible. It's a mixed, it's an improper fraction with a mixed number, so we don't do that. So 9 goes into 14 one time. So this is saying 2 plus 1 and 5/9, right? Because 14/9 is the same thing as 1 and 5/9. So I've got 2 plus 1, which is 3. And 5/9. So all of that for 3 and 5/9. So that's the area model. Finding the area, the length and the width of each one of the small boxes, adding that all together, which means I have to get a common denominator. Now, we did not need a common denominator to multiply. The kids have found the trick for that. We've talked about that. Now, the way that to check their work, as I call it the check mark method, we're simply just going to turn these into improper fractions. So 2 times 3, so I call it check mark because you go down, you go 2 times 3, and then you go up and you create that check mark. You add. So if I went up like I should, that makes an addition symbol. So 2 times 3 is 6, plus 2 is 8. And the denominator was 3, so thirds. This one, 1 times 3, plus 1, so 4/3. And then it's that trick that they talked about, A over B times C over D. We got 8 times 4, so numerator times numerator equals numerator. Denominator times denominator equals denominator. See how easy that was? 32/9. I can't leave it like that. So 9 goes into 32 3 times, which is 27. 32 minus 27 is 5, and my denominator was 9. And we get a smiley face because, look, these two are the same answer, which means I did it right. So smiley face. So they have to do all this for one problem. So they did the area model, and then they check it with the check mark method. They're probably going to need a separate sheet of paper, which I've already told them. And then we talked about what if it was wrong? No, we shouldn't erase all of this work. We should find where it went wrong and fix that one piece to then fix the total answer. We shouldn't start all over again unless everything you see is wrong. But I doubt that, because they know what they're doing for the most part. So then they need to do 3 and 5 like that, as well as 6. And 6 should have Kita as well. Have a good night.